4.1, the chain rule.
Oh, joy.
So in simple terms, this is the derivative of the outside times the derivative of the inside. Pretty chill. So we can now do things like this. Y equals the sine of 7 minus 5x. And in this case, they're actually telling us that u is 7 minus 5x, so that's the inside part there.
Oh, wow. I never would have guessed.
Sometimes people don't know. So, and sometimes what looks like it would be the inside may not be, and also, so anyways, yeah.
Virginia, I think next time you might have to tell me what the inside is.
All right, let's start nice and easy. Du dx. So take the derivative of u with respect to x. What do we get?
-5.
Yep, -5. Now I'm taking over here dy du. So I'm taking the derivative of this piece as a whole. So what is the derivative? Just, you can even pretend this is y equals the sine of u, essentially, is what we're saying. What is the derivative of sine?
Virginia, what's the derivative of sine?
Oh,
Cosine. Also, don't let me forget I have your test graded.
Oh yeah, it's on mine.
Same.
I think I know where I went wrong.
All right, so when we take the derivative of the whole function, we copy down exactly what's inside, okay? And then we take these two things and multiply them by each other. So y prime is -5 times the cosine of 7 minus 5x. Now, normally I won't write it this way, but the first few problems of this section are written this way to help you to start get a feel for the chain rule. So it's kind of like take two derivatives and smush them together, which is essentially all we're doing anyways, but just kind of a way to hopefully help. Oh, not 4, 6. Y equals 5 times the cotangent of 2 over x. And u is 2 over x.
Virginia, would you have guessed that u is 2 over x?
Yes. After the last one. Yes.
All right, let's start easy. What's the derivative of u?
-2. Perhaps.
-2x to the -2.
Alright.
Yeah,
So
I
this
wrote
would
it.
be 2x to the -1. When you subtract 1, it goes down, which
Okay. Did I? Well, I thought.
that's
I
what you
did
did
that.
on the test.
But I thought I went back and changed it. Did I
Mm-mm.
not?
Mm-mm.
Darn it.
At least not where I looked.
Because I did all of them wrong, and I went back. I was like, oh wait, I should be subtracting these.
I think there was one you didn't catch it on.
Darn.
All right, so
Yeah, I just changed that to the 2x to the -1.
yeah. Now, when we end up plugging this in, we'll probably do -2 over x squared just for the sake of multiplying at the end, but either way is fine. What is the derivative of 5 times the cotangent of u? So dy du.
Negative secant squared. Do we keep the 5?
Yes, but it's not secant.
I mean, cosecant.
Yeah, -5 cosecant squared of, and then what goes in parentheses instead of it being x, it's whatever that u value is, so 2 minus x, or 2 divided by x, not 2 minus x, what in the world? Then I multiply these things times each other. So negative 5 times the negative 2 over x squared is just going to be 10 over x squared times the cosecant squared of 2 over x.
You're missing the prime on your y.
I got sidetracked because I also left the parentheses off. All right, let's do one more where they tell us u, and then after that, I'm going to have to work for it.
Oh no.
Y equals secant of tangent of x. Bum, bum, bum. What do you think u is?
Tangent of
Yep.
If Virginia wasn't here, I never would have guessed that.
All right, what's the derivative of tangent of x?
secant squared.
Yep, secant squared of x. What's the derivative of secant?
Secant of x. Tangent of x.
Yep, so it's going to be secant of the tangent of x times tangent of the tangent of x.
Wait, how'd you get that?
Because it's secant of x, tangent of x, but my x value is tangent of x, so I have to plug that in.
Makes sense.
Tangent of x is u, so this is the derivative of the secant of u.
Secant of me.
Oh.
I was like, you look so confused. I don't know how else to say it another way.
I got there eventually.
So then multiply y prime is secant squared of x times secant of tangent of x times tangent of x. So, doesn't look pretty, but nonetheless, the answer.
I guess it's alright. It's not that ugly.
All right, an object moves along the x-axis so that its position at any time t greater than or equal to 0 is given by x of t equals s of t. Find the velocity of the object as a function of t. So 10, s equals t cosine of pi minus 4t.
I minus 14. Sounds very
So-
similar to something else.
I have position, and I'm looking for velocity, so what does that tell me I need to do?
The derivative.
The derivative. So v equals, now what do I have here?
Product.
And
Chain.
product and a chain rule. Okay? This is where they start to get a little bit dicey. So, nice and easy. Derivative of the first thing. I know it's not the order we normally do it, but it would just be 1. So then we'll have cosine of pi minus 4t plus t times, now I need to take the derivative of this. So what is u?
Pi minus 4t.
Yes, so what is the derivative of that?
Negative 1.
Negative 4?
That's what I said.
Aw.
The derivative of pi minus 4t.
Oh. Yes, negative 4.
So negative 4 times,
I need to hear the story behind this.
what is the derivative of cosine?
Negative sign.
Negative sign. So since this was negative and that's negative, we can make this a positive. and then it's the sine of pi minus 4t. Now, I usually try to make this look a little prettier. So, cosine of pi minus 4t plus 4t sine of pi minus 4t.
I wish we could like factor out a pi minus 4t.
Yeah, but you cannot. Okay. Next.
Oh no. I don't like that one.
14. Y equals, in parentheses, cosecant of x plus cotangent of x raised to the negative 1. So this one's a little different, okay, because the other ones have had pretty much a trig function, or I think all of them basically had a trig function to this point, right? And this one still has a trig function, but it just looks a little different. So the derivative of the outside is the parentheses as a whole. So ignore everything inside of it. What is the derivative of that parentheses?
Negative 1 to the negative 2.
Yes, okay. So negative 1 times everything inside stays the same, so you just copy it down exactly as it is. Raised to the negative 2. Then it gets multiplied by the derivative of the inside. So what's the derivative of cosecant of x?
Negative cosecant of x, cotangent of x.
Yep. Plus, what's the derivative of cotangent of x?
Secant squared x. What? Oh, wait, let me think.
No, it's negative
What?
cosecant squared.
Oh,
X.
yeah.
You were saying the one for tangent.
You did that earlier too.
Oh, well.
Yeah.
Trying my best.
Minor details.
And
Yeah.
your best is failing.
It's fine. All right, so
Just don't do this in physics.
we're not done, just to be clear. I need to keep going.
Do you really?
So this piece right here that's being raised to the negative 2 is moving to the bottom because it's a negative exponent. So cosecant of x plus cotangent of x squared. Now, everything's being multiplied. So this negative 1, I'm going to multiply by this stuff on top. So it's going to make both of these become positive. Because this is negative and this is negative, so it's just going to make all that go away. So we're going to have cosecant of x, cotangent of x, minus, plus cosecant squared of x. Now, is there anything in common that I can factor, Josh?
I think we could do cosecant.
Yep, so I'm going to take out a cosecant of x. Leaves me with cotangent of x plus cosecant of x over cosecant of x plus cotangent of x squared. Now what happens?
We can cancel a squared and a cotangent of x plus cosecant of x.
Yep, so I can get rid of that. So ultimately, I am left with cosecant of x over cosecant of x plus cotangent of x for my final answer. So typically it's not the calculus that kills people on these problems. It's the algebra part of moving trig functions around and all of that. true. Because in a minute, they're going to give us a point to plug in. Or, well, we may save that part for tomorrow. TBD. I usually do this section in sections, so we'll see if we're going to do that today or not. Or let you start off easy and do these problems, and then we'll just keep adding to them.
No, that sounds terrifying.
All right, number 16. Y equals x cubed times 2x minus 5 raised to the 4th. So what do I have going on here?
A lot.
Yes, a lot.
Too much.
What rules am I going to be dealing with?
Was it the multiply?
Product rule.
Yeah, that thing.
All right, so derivative of the first would be what?
3x squared.
3x squared times this piece as it is plus first piece x cubed times the derivative of this piece. Let's see if y'all have figured out what the derivative of this would be.
I want to guess, but I might be wrong.
That's okay.
4 times 2 to the 3rd.
I mean, that's what I wrote.
4 times 2 to the 3rd.
Maybe not. Well, maybe. I don't know. That's what I wrote. So, at least we're on the same
Wrong.
page here. Might be the wrong page, but same page, so.
Yeah.
2 to the 3rd?
In other words, 8.
Thank you, Josh. Okay, 4. I'm just going to put it out here so that I can save an extra step in a minute. Okay, the derivative of the outside. 4 times what's in parentheses. 2x minus 5 cubed
Oh.
Bruh.
times the derivative of the inside, which is
8. Not 8.
2.
4 times. What? No.
2.
What's
2. I quit.
Well, there was an 8 somewhere.
No, there wasn't.
Well, we multiply the 2 and the 4, then you get 8.
Yeah, you get 8.
Jeez. All right, this ends up giving me
This is sad.
3x squared times 2x minus 5 raised to the 4th plus 8x cubed times 2x minus 5 cubed.
See,
There
is
was
an
an
8.
I need to make sure I know what's
Do you really?
going on. Yes.
Hold on.
Dude, drink your water. How many of those have you had today?
I don't know, I refilled it, but because there was like a tiny bit left.
You should try that. Girl, what? Blow across the blow across the top. Harder, Virginia.
Okay. Supposedly there's some way you can reduce this farther, but I would just leave this here. If it was me personally.
Yeah, I don't really think.
Haven't
we should
quite
go
figured
up
out
to-
how they got to the answer that they got to, so.
I mean, have you tried plugging in numbers for x and seeing if it gives the same number?
Their answer is this.
Okay, we'll call x 2. Okay.
I know it's true. I'm just saying I don't know how they got there.
Well, I didn't know it was true. So,
Because, like, if you take an x squared out, that would leave you with and a 2x minus 5 cubed out. That would leave you with 3 times this plus 8 x. I don't know. Anyways, I would leave it like that. The book actually has both answers. They have this is equal to this. So, I don't know.
but they don't have anything in between.
Correct. I don't know. All right, 18. Y equals 4 times the square root of secant of x plus tangent of x. So this one's a little different than the other chain rules we've had. What's different about this one?
It's the things to the 1/2.
Okay, it's a radical, so it's raised to the 1/2. So I will pretty much always rewrite radicals as something to the 1/2 to not get confused. So 4 times secant of x plus tangent of x to the 1/2. And now I need to take the derivative. So what is the outside derivative?
Two.
And
Times secant of x
and whatnot.
plus tangent of x
To the negative 1/2.
negative 1.
Okay, beautiful, beautiful. Off to a good start. Times,
Say that now.
what's the derivative of the inside?
I got this.
Sure you
Um,
do.
Wait, hold on. Let me see. Does it start with 2?
What is this? No, what is the
Oh.
derivative of secant?
Oh.
The derivative of the inside. Ignore everything except for what's in parentheses.
Okay.
I'll just wait for you to say it so I can check my answer.
Secant of x, tangent of x, plus no, not negative. It would be secant squared x.
Yes.
My original answer was we're finding tangent squared of x instead of secant squared of x. I wrote the wrong letters.
So we could take a secant out of this top part if we wanted to. Drop paperclip. This piece over here in parentheses is going to go to the bottom and become either, well, I'll show you. So 2 times, I'm going to take a secant out, so secant of x, and then in parentheses, tangent of x plus secant of x over secant of x plus tangent of x to the 1/2. And you can leave it here. Or if I take a secant out of this piece, okay, so look at this. Is this match this?
Yeah.
What exponent's on this?
1.
What exponent's up here?
Negative 1/2.
So could I subtract them?
I love subtraction.
So if I did that, I would get 2 secant of x times the square root of secant of x plus tangent of x. And either would be sufficient. So it's all about how you simplify it. And the big thing that I've noticed with like the AP like prep stuff is that sometimes like they may have you write it in different forms. So it's not necessarily that you like when you're checking your answer that you got a wrong answer, but it might just be that it's in a different form than the way that they're asking for it on a multiple choice question. So you kind of just got to look through and see what makes sense. Let's see. Let's go back to an easier one. 24. Y equals the square root of the tangent of 5x. Well, I say this one's easier. It might actually not be. Now, let me explain to you why it's not. Okay? So, this is the same as the tangent of 5x all raised to the 1/2, correct? So this is actually a double chain rule. Okay? So I first am going to take the derivative of the whole piece. Okay? So if I just told you, ignore what's in the parentheses. If I just told you to take the derivative, what would you tell me the derivative of the outside is?
1/2
To the negative 1/2.
negative 1/2.
Yes. Okay? So that's the first part. So 1/2 times what's inside, the tangent of 5x.
Shouldn't we specify that that's y prime, not y?
I will in a second.
Oh, okay.
Didn't let me get that far, Josh.
Trying to get cookie points.
No, we didn't get cookie points for something earlier when she didn't forget the prime on the rise. I don't think we're gonna get cookie points for that.
All right, so that's the derivative of the outside. What's our normal next step?
Prime.
The derivative of the inside.
The derivative of the inside, which is the tangent of 5x.
I think my answer is better.
Okay? What is the derivative of tangent?
Secant square root. Whatever we're calling it.
Okay? So secant squared of whatever's in here. So 5x. Then lastly, I need the derivative of the very inside because the derivative of tangent still has something else inside I need to take the derivative of. So what is the derivative of 5x? 5.
So we're just multiplying everything there.
Yes.
Cool. Not really, but cool.
So our answer ends up being 5 secant squared of 5x over 2 times, I'm going to leave it as 1/2, tangent of 5x to the 1/2. Obviously, normally we wouldn't want to leave it there, so we could actually leave it up on the top as a negative exponent. Either way is fine. If you wanted to write tangent of 5x under a radical, also totally fine. Up to you. But I would probably just go here and call it a day. One more. Holy macaroni, that one's got a quadruple one.
Ew. Why would you ever
We'll
tell
start
us
there
that?
tomorrow. 26. R equals secant of 2 theta, tangent of 2 theta. So what do we notice about this? What are we going to have? And
Change.
how many? 2, because this is going to be a chain rule and this is going to be a chain rule.
Separate chain rules, Virginia.
I said 2.
R prime, Josh, equals. All right, derivative of the first. What's the derivative of secant of 2 theta?
Secant of theta, tangent of theta.
2 theta.
Yeah, Virginia.
Sorry.
Oh, so we just
What's the
copy
derivative
that.
of 2 theta?
2.
2, so I'm going to go ahead and put that out here. Times tangent of 2 theta plus, copy down the first, secant of 2 theta times, what's the derivative of tangent of 2 theta?
Secant. Wait, 2 squared theta.
Square root of 2 theta. What's the derivative of 2 theta?
Two.
2.
2. Yes.
So I'm going to put the 2 out front. Now I just need to multiply. So this is going to be 2 secant of 2 theta tangent squared of 2 theta plus 2 secant cubed of 2 theta. And as far as I'm concerned, you could leave it there. If you really wanted to factor out a 2 secant of 2 theta, you could if you were just so inclined, but I think that's reasonable there.
Wait, can you like explain how you got each part of like the derivative?
Yeah. So derivative of secant of 2 theta is secant of 2 theta tangent of 2 theta times the derivative of the inside, which would just be 2. So I put the 2 out front. I just didn't put it behind. I just put it in front. Times this piece, because I'm in a product rule. So it's the derivative of the first times the second. So times tangent of 2 theta. Plus, copy down the first part exactly as it is. So secant of 2 theta times the derivative of this part. Derivative of tangent is secant squared. So that's going to be secant squared of 2 theta. Derivative of 2 theta is 2. So I just went ahead and threw the 2 out front.
Okay.
I love drawing numbers.
All right, I'm going to go ahead and give you a couple problems because if you wait and do all of this at the end of the section, you're probably going to be miserable. 1, 9, 19, 25, and 27. And I'm going to do a couple more of that kind for you tomorrow, and then we'll move into composite functions and setting those up and what that looks like. So...